I'm Stephen Foskett, the organizer of the Tech Field Day event series. The video you're about to watch is part of the Storage Field Day presentations held in San Jose, California in October of 2016. We welcome Primary Data here. They've presented many times, and if you'd like to see more videos like this from Primary and other companies, you can go to our YouTube channel, youtube.com/techfieldday. If you'd like to learn more about the Tech Field Day event, just go to techfieldday.com.
Thanks, everyone. My name is Kaycee Lai, Senior Vice President of Worldwide Field Operations at Primary Data. So I noticed there's quite a few international folks in the audience. And that makes sense because when I first saw the time slot, I said, there's no IT guys that wake up at 8 a.m. Come on. So that finally makes sense. I think there's a gentleman from the Netherlands, right? John, I'm going to speak Dutch with you later because I speak Dutch every day at 6:30 a.m. And so I'm getting a little withdrawal symptoms right now because I'm not speaking Dutch, so I'm going to catch up with you later. We have a customer in Holland, so that's what keeps me up or makes me get up at 5:30 a.m. every morning. So what you guys didn't know is that for those of you guys who are actually professional IT administrators, this is a sales pitch. We've set it up. We open with this good-looking guy, Lance Smith, to kind of charm you. David wowed you with the technology. Douglas is super credible, lets you know that things work. And I'm actually going to now tell you how much it costs and why you need to buy. So you guys didn't know this, but it was a pretty crafty setup on our part. So I'm actually going to go through and talk about why customers buy Primary Data. Well, what's in it for them? What are the benefits that they see? And actually share some use cases and examples from certain customers. And then Douglas and I are going to tag team on showing you guys a live demo. And the key word is live. And so thanks for the hardwire. Great. Now I can't blame the Wi-Fi latency if something doesn't, happen the way it should. So this actually tells you the main reasons why customers look to Primary Data. And David did a good job kind of touching upon it. The big, first and foremost, is sort of the visibility to really understand what your data needs are, how the data is actually consuming your storage resources, where the dark data is, how active the data is. And then having that next level of visibility down in understanding your storage capabilities so that you can understand how best to align your storage resources to match your data needs. And you only want to do that because there's certain things like cost savings you want to do. You want to have the ability to say, I'm going to move this dark data here, I'm going to promote this hot data here, I'm going to have more intelligent planning in assessing what I need to buy for the future. And this is now becoming a automated monitoring, alerting, and automation tool now. So you don't have to manually do this every single time. And so this allows you to set it and forget it and have very intelligent automation throughout your environment. So as any of us in storage knows, if a vendor is trying to get a PO through you, you and your boss is going to ask not only how much does it cost, but how much money can you actually save. So these are actually examples of customers we have that we're working with in terms of the TCO that we build with them. And so we first understand, given their environment and the use case, what they're trying to do, and how much it currently costs them today, and how much it will cost them if they were to do an alternative without Primary Data, and then with Primary Data. So as you can see, the savings usually are over 50%. And by the way, this actually includes the cost of the Primary Data solution in there as well. So a lot of vendors will show you their TCO, but it doesn't have the cost of their solution. Looks fantastic, and then the cost of their solution goes in, and your whole TCO blows up. So as you can see, it's a pretty dramatic in terms of working with the global media and entertainment leader. Without us, it's $13.2 million that they would be spending, and with us, including the cost of Primary Data, $6.8 million. And along with that, as David talked to you earlier, for scale out, it's not just media and entertainment, it's also something like life sciences. So we are also working with a leading cancer research company. And for them to be able to cut their storage costs by half, including the cost of Primary Data, is very significant. So we wanted to focus specifically on a particular vertical, as you guys heard earlier. So media and entertainment is one of them. And so these are the market needs for media entertainment, right? People are trying to deal with how do I get content to market as fast as I can? And the data sets for media entertainment are huge. There's no media entertainment customer I meet is under 2 petabytes, right? It's a lot of them are way above 10 petabytes, and so it keeps growing. Their assets keep growing with every movie, every project that they take on, which makes it even harder for them to figure out what they have, how much they need to retain online, especially if a movie does well and there are sequels that they have to have. You know, how do you now juggle, the ability to find stuff from 4 years ago? So these are some of the challenges that they have, and then throw another complexity there is their distributed teams, right? Sometimes they could have teams in Vancouver, teams in LA. They have to work with each other, or teams in India, et cetera, with different time zones. How do you deal with concurrent access? How do you deal with latency? Someone in India trying to access a file that's located in LA, how do you ensure that they get the best performance? And so all these really create these complex challenges that primary data looks to solve around how do you make the most efficient use of capital, specifically on the storage side, but also how do you allow the data to be agile and mobile? With what David and Douglas talked about with the notion of objectives and being able to automate the movement of data to best address things like performance, location, and latency. And overall, how do you make sure that this delivers a fantastic ROI so that as your business scales and your environment scales, you can keep up with that? We actually, talked to a number of healthcare providers, which also is a big scale-out vertical, and a lot of them have told us, they said, look, Isilon was great. We started out a petabyte, 2 petabytes. We might need to go to 20 petabytes, and given the current cost structure and also the complexity of management, we're not sure that's what we want to do. We're not sure we can handle that, and so this is where they start talking to primary data. And so the benefits that we give for customers, as Dave has talked about, specifically in scale-out environments, is given the architecture that we have where we're separating metadata from data, you will get this acceleration of metadata performance. And so things like lookup, seeks, get-atters, which on the surface to users, it might look like, oh, I just need to throw more flash at it. But as David talked about with NFSv3, it's this very, very inefficient protocol that could be 15 operations involved in just looking up one file. These are some of the operations that primary data helps accelerate, as well as leveraging PNFS for better parallel data path performance. And yes.
A question, just it's not coming out in English. I could try Dutch.
Yeah, go.
I only have one Dutch sentence, and it's not appropriate. We've covered that you do more than just NFS, right?
Yes.
But what about an environment that is already using object as object, and then they want to use your software is PNFS, which I'm assuming talks NFS. How does that?
Yeah. So today, given our current product, we will archive to object. So we don't allow concurrent active read-write to object here today, but it is on the roadmap for us to be able to support object as an active storage tier, where we would be able to, at the client level, do the protocol translation from file to object so your clients can natively access an S3 storage target, for example, without you having to change anything from an application perspective.
And what about block?
And I'm going to have my awesome CTO here answer that.
Yeah, so today we do file on object as well as object on file. But if you're going just object to object, it's inefficient to go object through file to object. So in future, we're going to have the ability to mux object stores and have native object APIs that don't have to promote data into a file world if the access semantics are just object. So it was keen of you to point out that it would be inefficient to promote object to file just to then turn around and offer access to it as object. So while we do ultimately have the ability to offer object interfaces and consume object storage, it's in an inefficient manner right now to go through file in between. So in the future, it'll be a native object on object, which will allow individual objects to be granularly placed across different object stores and migrated between them and have all of that benefit of the virtualization, but in a way that's native for object. Going to your question about block, Today we support block by taking the individual LUNs and presenting them in the namespace of file as files. So now instead of managing LUNs out in the ether, actually LUNs out in the SAN, it's not on Ethernet, but they're not anchored to anything. You don't have a namespace for them. They're just LUNs off there on devices. They're scoped by the SAN that they're on, and that's actually problematic, right? Here, you graph them into a namespace which can be visible everywhere, and they show up as if they were on a file. Interestingly enough, though, when you have an application that wants to consume that block device LUN, it might resolve it through the namespace, but ultimately it's accessing the block on block without having to go through file, except for with the metadata operations of resolving it and opening it in the first place. Does that make sense? So we are using, yeah.
So I'll give the quick sales guy answer to that.
We can do it for you.
We can do it for you. We basically put file on top of block, so you convert, the application still speaks block. We translate from block to file, and then the storage still speaks block, so you're still connecting fiber channel. We can talk you through the implementation afterwards, but
Sounds very
that's
NetApp-y.
So it's different. It's very different though, because once you split the control plane and metadata from the data plane, now we can promote block to file from a metadata perspective when you open the thing, right? Or when you close the thing. When you talk about the LUN as a whole, that's through a file system like namespace where you can manage what is the LUN you're talking about.
Ultimately, a block is
But from a data path perspective, it goes block to block without having to go through the inefficiencies of file. And that's what's so compelling, is that when you split the control plane from the data plane can be block on block, while the control plane can promote all of your, block devices scattered throughout the system and have them actually show up as nodes in a namespace.
That'd be an interesting thing to drop into the lexicon of software-defined storage.
correct. It's the multi-protocol access, right? It's
Yeah.
giving you that freedom to actually now choose different protocols and different storage types, which if you look at other software-defined storage, you're still locked into and contained to one single protocol.
Yes.
Right.
And it's because the metadata and the control plane are inextricably linked to the data access plane. It's as if,
Right.
So we talk about it as the DNSification of storage, because today it's as if your DNS server had to subsequently proxy all the traffic to every IP address that it resolves. That's just a stupid model. But here, you can resolve what google.com is or what this LUN is, and once you've resolved it, you're going straight to it without the additional impact.
Yeah,
That's
it's a good
essentially a
analogy.
resource discovery mechanism.
Correct. Metadata for the resource discovery and all, but once it's connected the two together, you're going block on block. And the one exception, though, is that it's actually mapping those blocks. So it's giving you virtual LUNs similar to what's needed to offer vVols to VMware. So think of it as taking any SAN, which is a raw block device, and with the primary data technology, making it so those block devices can be dynamically incised and thin provisioned, et cetera, when they're offered up to the application. So there is a little bit more to it. And
Okay, we'll get to that later, but just
Yeah.
to summarize, you can natively talk block and file, and then you can archive today to object.
to object, and we offer an object interface, but to go through and access it, it has to unarchive it and stick it in file for it. That's why it's a little less efficient. If you're just going to do object on object and don't need the file semantics, it's a little less efficient because it has to promote it from object into file before the access out.
So there's 4 little letters here at the bottom, NVMe.
Yes.
Where's that come in?
So in the DataSphere, part of the product, which is where we do all the metadata operations, the best practice and recommended bill of materials is to have a server leveraging local NVMe. So in addition to the NoSQL
Well,
database,
that's good enough.
Yeah, that way it really accelerates that. And obviously the cost savings, right? being able to do now not just tiering based upon temperature, tiering based upon data type, tiering based upon time, tiering based upon what type of storage you want to go to, what type of latency levels you want, allows you to minimize the amount of expensive storage you have, allows you to actually free up cold data so you can reclaim tier 1 storage and leverage object storage adoption as well. And we do all this because this is the first solution that actually gets you visibility both at the client level and a storage level. So you always have a feedback loop mechanism of what's actually happening from a client perspective, what workloads it's generating, what objectives and needs from performance, cost, protection perspective, and the underlying capabilities of the storage, the performance capabilities, data services, capacity, et cetera, and constantly monitoring this in an automated fashion so that you can always make sure you're best utilizing your resources, which leads to cost savings. So let's talk about the media and entertainment customer results for a second here. So a lot of time when we go and talk to these customers, a lot of time it's, the problems are usually the same, right? They start with, hey, I need to accelerate performance for my metadata operations, for my temp and scratch base. And so that's definitely something that we can do for them, either leveraging existing storage, so leveraging their existing NetApp or Isilon, or even introducing cost-effective x86 servers with local storage. And then the automation of data archival or the automation of data tiering. So it might sound trivial because you have this in a lot of SAN arrays today, right? You have VMAX, VNX, et cetera. But it gets hard when you're at 10, 20 petabytes. And it just does, right? Everything gets much harder at scale. And also it gets hard when you have to span namespaces across different storage systems. And so this is what we offer from an automated perspective, sort of a vendor-neutral tiering system. The visibility, as we talked about, allows you to say, based upon which application, which type, what storage it needs, how it's going to consume it, you can make the best decision to avoid problems by placing it at the right place to begin with, and then setting in triggers to automatically move it as business conditions change. And then lastly, the architecture naturally lends itself to a scale-out type of architecture, so you can linearly scale out both performance and capacity. So this particular customer that we saw earlier in the slide, I'll just kind of talk about a little bit. This is an animation studio. They've made movies that you guys have watched or your kids have dragged you to the movie theaters to watch. They make many of my favorite movies. And they're one of the largest Isilon customers out there, right? So over 10 petabytes worth of information, worth of data. And originally we started talking to them for one use case, and that was just around metadata acceleration. Hey, we have a shot temp space here that if you guys can accelerate the metadata where they're having a hard time with both Isilon and NetApp, that could be a win. And sure, we can do that just as our natural architecture with DataSphere, leveraging the separation of the metadata and the data, and then processing the metadata operations on NVMe. But we also were able to show them that with the Isilon architecture, as David alluded to earlier, we can get rid of some of the natural inherent architectural bottlenecks of Isilon. Instead of having every file on one client go through a single NFS mount point, you can now have each client, each file talking directly to any storage node that you want. And so the result is you can significantly increase throughput for your Isilon. And why this is important, because if you look at a lot of scale-out customers, if you look at how much storage nodes they have in terms of capacity and how much actual data they really have utilized, it's sometimes a big difference. In this case, it was a 6x difference, right? So they bought 6 times more storage than they need. So right off the bat, if we can give them a 2 to 4 increase in throughput, that means they don't need 6 times more storage than they actually have. And so at that scale, power, space, and cooling also becomes very, very attractive as well.
I've got a slight problem with your math there.
Okay.
If you want to drop back one slide, 64% of 13 million is not 6 million of saving.
So I think it's you do 13 million minus 6.8 and take that number divided by the 13.
But the saving is the difference between what they did spend and what they could have spent. It's only a 50%.
That
saving.
number is just simply the difference between the 13 and the 6.8. So maybe we need to make the wording a little bit different.
Yeah.
But it's basically saying,
Yeah, you're
look,
inflating that number,
we're-
but the number is still pretty great.
the number is still great. Look, we saved them 6
it's about-
points.
It does seem to be off by a
Yeah.
bit.
It's-
6.8 might be 64%.
So we saved them
you got
6.4 million.
of
Yeah,
what
the other
they would've
solution
spent.
would have cost 64% more. You did not save them 64%.
You
The other
save them
solution-
the
so-
inverse of that.
Yeah.
40,
Correct.
the 40.
The other percent would have cost 2/3 more.
It would have cost
Correct.
13.2, but with us, it's 6.8. So we saved them 6.4.
Yeah, none of that math adds up to 64.
No, 6.4 million was
$6.4 million
saved,
dollars.
which is different than
64%
64%.
savings is not what, this
Yep,
is my
you're
my
right.
issue with correctness on the slide.
You're right.
Not with that it's,
Mea culpa, we should have checked the math on the slide.
Yeah.
But the math still works. Okay.
oh, it's still a massive saving.
Yes, yes. Tell you what, you get a 10% discount if you buy. How's that?
We're all witnesses. We're all witnesses.
You guys start and resell to any customer need a saving? A 5% discount?
So here are the numbers specifically on the isilon test that we did to show them. And this was on a small isilon, just kind of as a proof of concept to kind of get an idea. And that's why, the numbers itself may not be earth-shattering, right? 15,000 IOPS and 35,000. But it's the relative gain on the same workload and the same platform, just by adding primary data, what you can get in terms of increase, what you can get in terms of decreasing latency, and what you can do from increasing the bandwidth. And all that translates not just to a better customer experience, better performance, but it means less nodes that you have to buy, given the isilon architecture, right? Which translates to real hard dollar savings.
What does that mean, increasing the bandwidth?
So if you do, we actually use FIO as the benchmark tool for here, and that's basically with isilon right now. So if we did 3 files, for example, in a single client, and if you're writing those 3 files to the storage nodes, they all have to go one at a time through the same NFS mount point. And so we can now, with primary data, now those 3 files can concurrently go to 3 different storage nodes. So you're aggregating the available bandwidth across 3.
Finer granular distribution of the load across interfaces on the gateways and across gateways.
That probably wouldn't fit above the column.
Yeah.
Yeah. This is where we have to take some liberties to make it fit on the slide.
Okay, I just wanted to make sure I understood there.